First of all, I want to thank everyone for being here tonight. It is our hope that when you leave here, you have a better understanding of the water system and how it works, and the terminology that's used in the water industry. When I started here 5 months ago, the water system, in my opinion, I'm trying to think how to describe the water system, but in my opinion, it seemed kind of in disarray. We were under a long-term boil advisory, an irrigation ban, we had IDEM involved, and a building moratorium. And here we are 5 months later. Today the advisory's been lifted. We are allowing irrigation. We're in the good graces with IDEM. We're talking with developers. And while I'd like to take credit for that, I can't. It's because the town employs very capable, intelligent, and hardworking staff that care about the town and have your best interest in mind. And they work very hard to get us on our feet today. So before I turn it over to the engineers, I have a letter that I was asked to share with you. This is from IDEM. We received it last week, and just a couple of key points. We did have a meeting with IDEM on August 4th with the engineers and some of the council members and myself and some of the water staff. It says on August 4th, 2025, a meeting was held between IDEM and members of the Cedar Lake Waterworks, as well as Christopher Burke Engineering, to discuss the contents of a master plan received by IDEM on July 31st, 2025. The aim of this meeting, as well as the master plan, was to showcase a plan for future development for Cedar Lake water system and to address concerns regarding capacity as detailed in a letter from IDEM to Cedar Lake dated August 8, 2024. The master plan that they are talking about is the master plan that our engineers will be presenting and answering questions on. The letter goes on to say IDEM has determined that a sufficient plan is in place to address capacity concerns. Cedar Lake's Waterworks is now eligible to submit NOI applications. The passage of the drought plan for irrigation is a great step in helping you maintain the capacity and alleviate spikes in usage. So while this is a positive step forward, it does not mean that the floodgates are open for development, but we are slowly getting back on our feet, getting to where we want to be. The last thing, before I turn this over to Kevin Baldwin from CBEL, I want to make very clear what the purpose of this meeting is tonight, and that is to inform you of the water master plan, where we are at with that, what their engineers have come up with, and then answer questions that you might have. And before we open the floor for questions, I want to make it very clear that this is an informational meeting. If you have questions about our water system, if you have questions about how we got to where we are or what our plan is moving forward, I would invite you to ask those questions, but I do not want this to turn into a pointing fingers and placing blames and you didn't do this and this and this. So I want it to be a very positive meeting and a very positive outcome for everybody. So with that, I will turn the time over to Kevin Baldwin.
Hello everyone, my name is Kevin Baldwin. I'm with Christopher Burke Engineering. I'm a mechanical engineer that specializes in water system modeling and water system audits. We have about 15-20 slides that are on the screen, so make sure you're able to kind of see onto the screen. This is shared online right now. To be very clear that the slides that are being shown tonight will be posted, or actually might have already been posted on the websites, so you can download them. These are designed to be a public document so that you can take a look and see what else is involved. So I'm going to go through probably about 15-20 minutes onto the first portion of the slide. I have some questions and answers that are already designed to kind of talk about some of the things that have already been brought up in the past, and then we'll open it to the floor for that. Let's see if the dongle will work. Maybe not. Oh, there we go. Cliff is helping me. Thanks, Cliff. Topics for tonight's discussion is for common terminology that's within a potable water system, a system overview of what you see in town, what is a water model. We'll explain what calculations and computations we are able to use to help with the master plan. Irrigation systems, we'll talk about it very briefly, what is involved with the master plan, and then proposed improvements to get us back on track. Then we will start the question and answer question and answer discussions after all that is done. All right, there it goes now. All right, some terminology. Potable water, you're seeing this term a lot. Potable water is definitely for our drinking water. It's for our disinfected and our treated water that we consume. So that's to be very clear that a lot of what you will be hearing tonight is of the pressurized system that we all use in town. The water source for the town is a shallow bedrock aquifer. It's about 200 to 400 feet below us, and that is the current source that you have in town. Distribution system is a pressurized network of the water mains that are being used. And again, these slides are going to be online if you want to go through these and make sure. We just wanted to make sure that people are aware of the terms that we're going to be using tonight. Water main is what we use to convey the potable water through the distribution in town. The typical sizes are 4-inch to 16-inch water mains. A fire hydrant is what you see, is what actually one of the few things you'll see of a water system that's above grade is a fire hydrant. That's kind of a connection point to the distribution system, used for fire protection, used for maintenance, used for testing and flushing of the system. An isolation valve is a valve to control the flow of water. That's how you're able to shut off or to turn on your water system. A service connection is a water service line that's connecting from the distribution system to a customer's property and interior plumbing fixtures. A B-box or a curb box is something you've heard for shutting off the property's water service connection. And then a water meter is how you can measure the flow of water that is being consumed. Go to the next slide. There it goes. Well pumps. So we're kind of going to the pumps and tanks for this slide. A well pump is a pump to extract the water from the underground water aquifer and to bring it to the surface. A booster pump is what normally you'd see at Robin's Nest, the pump station that's on the east side of the lake. It boosts the pressure from a ground storage tank, and then it is pressured pumped up to a higher pressure that's suitable for the distribution system. Hydropneumatic tank, ground storage tank, and elevated tank are types of water tanks that are either at ground level or suspended in the air. And a SCADA system, you'll hear this term tonight a little bit, is called supervisory control and data acquisition. These are control measures that will help a water system be able to react to a event or a situation that's on the pressurized system. So SCADA is the term you'll be hearing tonight. A hydraulic grade line is a term that we would use for the energy that's on the fluid, so how much pressure is on your system, so that's how much pressure is coming out of your faucet. And lastly, pressure, pounds per square inch, is usually the PSI that we would be talking about on a system. So I know there's lots of terms onto there, but that's something we wanted to have for you in the slide deck to make sure that the terminology is very clear of what we're talking about tonight. Next slide is IDEM. You'll also be hearing this term a lot, is Indiana Department of Environmental Management. We, for this discussion, is involved with the Drinking Water Branch, and they enforce the requirements of the Federal State Drinking Water Act, SDWA, and so these requirements are there to verify that the public water supply system is in compliance with the regulations that are through inspections, through inventories, disinfection treatment requirements, developments, and operator certifications, and also permitting. So a lot of everything that's wholly involved with this particular system, IDEM is the agency that is overseeing these discussions. Cedar Lake. So a system overview. Cedar Lake is unique because you have 3 separate public water systems. So there's the west side, also known as Utility Inc. There's the east side, that's also known as Robin's Nest, and where we are close by in Paradise Cove is also known as Lighthouse, or the WPM. So there's about 50 miles of water main that is within your town, and there's about 3,100 service connections that's on the west side, about 350 on the east side, and Paradise Cove is starting up with only 4 right now, with this building included at Town Hall. So, wanted to give you a magnitude of the size of system that's around the lake, but the thing is that there are some discussions to have on the separate water systems for the west side and the east side, so we want to be clear about that. Some major system components that are involved with the system as a whole is that there are 3 storage facilities There is, on the east side, you have the tank at Crystal Oaks, that's elevated in the air. You have the Parish tank that's on the west side, and then Paradise Cove has its pumps coming from there. There are 3 hydropneumatic tanks that help with the pressure around town. There are 3 high service booster pumps that are at Robin's Nest on the east side, and 8 supply wells that are throughout the town. Water consumption data, wanted to be very clear of the usage that's happening on all sides of the lake, is the west side normally goes through more than 500,000 gallons a day in an average use, and then for a maximum day is 1.3 million gallons plus per day during the summertime. On the east side, a little bit smaller system, about 90,000 gallons a day on average usage and 170,000 gallons for summertime. Paradise Cove is only serving the 4 connections that we showed before. They average go about 14,000 gallons and 28,000 gallons for average and max. With that said, the discussions, we wanted to show a graphic for the west side demand trends. There are 2 lines that are on the screen. The middle line is showing the average day flow, so what I was saying at the almost 600,000 gallons mark, and then there's a second line, the bolder blue line on the top of the graph that is showing the maximum usage at almost 1.3 million gallons a day. There are 4 peaks that are happening. The first of the peak is actually the whole season of 2021 in its usage. On the left side of the graph is the amount of gallons used during each of the days. And so you can see at the leftmost side of the graph is your winter time. So December, January, February, March time, you can see how the usage is lower than your average you would have for the entire season. Once you get ramping up into the March, April, May, June range is when you see the trending of your demand and your usage going up above the average usage. So in 2021, you had an average of about 500,000 gallons, and it would spike almost over 1 million gallons a day. In 2022, there was a larger usage that was happening in the summertime, and then in 2023, when there was an event that happened, you can see there were a couple spikes that happened over the maximum line that was there. Now, the interesting thing that's in between the 3rd and 4th location is that there are some mini spikes that are happening at the October, November, December time of 2023. There were multiple spikes that had happened that are either fire flow events or water main breaks that happened during that time frame. And then you can see in 2024, so which is the furthest right peak that's on here, you can see it had went back down to what 2022 demands were using. Why I bring up this kind of discussion is that it was of the opinion and of the discussion is that there were multiple leaks that were happening on the west side that were then repaired to then go in between the 2023 season to the 2024 season. There's also, of course, the high droughts usage that was happening, so that compounded on top of water main leaks that were going on. So with this said, we were able to determine of the amount of usage that is normal to what is happening on the west side. That's why we wanted to show the graphic of what is normally happening. We have seen the preliminary numbers for this season, for 2025. It is mimicking what 2024 is looking like. We do not have any spikes because of the restrictions on irrigation. There was no major issues that were happening on the west side, so that was a positive on what had transpired from this past season. Again, at the end, if you want to talk more about this one, we'll go back on slides and we'll go from there. What is a water model? A water model is actually a tool that we can simulate how the system is to be simulated in scenarios and how it can be analyzed on how the behavior of the system works at different scenarios. So it uses equations to calculate pressure, fire flow, pipe flows within, flushing operations, how old the water is when it starts to finish, water quality, temporary shutdown scenarios. We're able to mimic how valves are turned off and how the water reacts, and then water replacement programs and capital improvements. So using this type of water model is able to use as an informed decision-making tool it helps with municipal comprehensive plans like we're talking about for master plans and for future capital improvements. So with the water model, we're able to put in demands, we're able to put in elevations in town, we're able to simulate with irrigation systems being turned on and to mimic an average day scenario and a maximum day scenario during the summertime. Irrigation systems, a method to deliver water to typical landscape areas. Most of these irrigation systems, if not, it should be all of them, is that they must be isolated from the distribution system with an RPZ valve or a reduced pressure zone valve. And this makes the direction of flow go only one direction towards the customer. And this prevents a cross-contamination from the customer side to the distribution side. So because of the increased seasonal usage in town, we wanted to make sure that we were accommodating the irrigation usage that's been happening in the past. Potable Water Master Plan. So the idea of what we're all here to talk about tonight is helping the town with a roadmap to guide the future of the potable water system. And so this utilizes the water model to analyze the improvements that's been talked about for many years. It helps identify deficiencies and make recommendations to improve the overall performance for all of the systems in town. And usually master plans are typically updated every 5 to 10 years. And then this is usually highly sensitive information, therefore the entire report will not be made public. But we're trying to show the major pieces of the master plan tonight of what the improvements are. Proposed improvements. In the near term, a couple bullet points on how these are. So the first bullet point is the SCADA system upgrade. And what the SCADA system is able to do is to help the water operators actually remotely monitor flows, pressures, tower levels, and pump status at each of the locations that they are installed in. And so that's why it is one of our top recommendations to have the controls be upgraded so that the operators are able to react faster to an event that is happening in town. Next one is additional well production and storage in the west. Is recommended to at least have 2 times the amount of average day flow for storage. Existing west system is deficient by 1 million gallons. Larger backbone of water mains in the west and east. This helps with redundancy of the water system to help if there is a break on a major artery that it's able to have redundancy coming around on another direction. And then the last one for the near term is asset maintenance and leak detection programs. So asset management's like flushing programs, being able to flush hydrants, being able to valve turn, make sure things are operating correctly, and leak detection programs. There's been lots of advances over the years on how leaks are able to be detected from above grade. Long term. In the next 3 to 5 years, we're recommending of the merging of Paradise Cove and Robin's Nest system in the east, the expansion of the east system to connect to Crystal Oaks Tower on the northeast part of the area, and also have well house upgrades to Paradise Cove. Larger backbone mains, again, is also put onto here to help with improving of the redundancy of the entire system, and then also incorporating a water main replacement program to be proactive with the replacements of older mains that are in town, and it usually coincides with roadway improvement plans. So that's usually trying to make sure that we get the utilities fixed before roads are fixed is usually the idea of that. The topic of future additional tanks and well siting studies, we had looked at 6 locations potentially on the west side. The criteria that we usually consider to help rank the decision is as follows, is the tank, an elevated tank usually within an airport approach? Is the location on town-owned property? Is it centrally located to the existing system? Is there any larger water main improvements required to connect to the tank to the overall distribution system? And is what the elevated tank overflow height is, how tall the tank is, are the major criteria that determines for looking at these sites. Two viable locations that's been talked about is the southeast corner of Parish and 151st Avenue, and then the west of Parish between 141st Avenue and 145th Avenue. Next steps for these tanks is further investigations on both of these sites, geological testing, fracture testing analysis to check the viability of the water that's underground, test wells and water quality testing. We need to check both of these sites that have been recommended to make sure that they are able to produce the gallonage or the volume that is necessary. We want to make sure that the actual quality of the water that's coming out of the ground is what's able to be sufficient for IDEM purposes. And so the next thing is really coordination with IDEM on all these pieces. And then we'd like to acquire cost estimates and proposals from tank manufacturers and well drillers to get price tags to make sure that they are in line with an overall plan, and then also coordination with developers on these particular discussions. All right, those are the major slides to talk about. And so to start the question and answer session, I have a handful of slides that hopefully will help jog some other questions and discussions, but I wanted to at least start off with some of these questions at the beginning. First question, does the proposed well and proposed tower site on the west system directly impact the existing service connections? And that is correct. That is a yes for both existing customers and developers and development. This will increase the production capacity and storage volume of the west system. So that's question number one. Question number two is, what is the estimated timeline on these particular projects? After the proposed site has been determined, a new well facility takes about a year to go through design, permitting, construction, electrical, testing, disinfection, inspections, and startup. So about a year's time is when the site has been determined that we're able to go through those pieces and go through permitting with IDEM. A new storage tank facility has a more restrictive schedule that's involved with it to adhere to painting at the correct time of the year. So typically the time frame is 1 to 2 years from design permitting to completion for an elevated or ground storage tank. Another question, can the west and east systems be combined into one larger system? So theoretically, yes, they can. Both of the elevated towers are actually at the correct height to do so. So the recommendation of the master plan keeps this in mind for all the proposed improvements for the future, that if it is viable to do so, that we would like to make sure that we are not going backwards with any of the proposed improvements to hinder that discussion. So connecting the system on the south or the north side of Cedar Lake has both positives and negatives to this discussion. So I know it's a little bit small text, but I wanted to at least read through a little bit of this. So all the supply wells, so the 8 supply wells that are in town would theoretically be interconnected to each other. You'd have increased capacity and you'd have increased flows from both sides of the lake. Both existing elevated tanks, again, will be interconnected. This will increase your capacity to do so. Expands the service area of the north and the south. You'll have connector mains that are on the north side of the lake and the south side that will increase the area that can be connected to the distribution system. And the elevations look favorable for static pressures, for your normal pressures in town, for these pieces to be interconnected to be able to do that. Now, some of the negatives, the north certainly is a flood-prone area, an environmentally sensitive area with a few wetlands that are involved on the north side and some on the south. You would need to have redundancy of water mains to make sure that there is resiliency of how, if one of the major arteries on the north or the south has a water main break, you would want to make sure you have a backup to do so in that sense. And then water main material would most likely need to be very resistant to the soil conditions that are involved. So it's a larger cost to be able to use the materials to do so in that sense. All right, a couple more slides. I got 2 more. I'm on 18 and 19, so we're almost there. When can the irrigation restrictions be lifted? So the restrictions will be discussed with the water operators to make sure, so that will be talked about at a later dates for those. But what we've seen from the restrictions that have happened have proven beneficial. There was no major usage spikes that were happening in 2025 during the summertime, and so it has been very beneficial for the town to be able to go through this particular season. Has the master plan accounted for new developments? And yes, that is correct. For all three systems, to the extent of what plans that have been provided to us, the demand projections also have accounted for a small percentage of transfers. If there, later on in the future, if there were residents that were interested to transfer over to the public water supply, we have accommodated that in our calculations to have residents be able to come over to the public water supply. The general idea of the proposed improvements is to increase all of the available fire flow for all customers, is what the general idea of the master plan is. All right, last slide, and we'll open up to the floor. Why 6 locations for the preliminary tank siting study? So the main answer is options, to see what is going to work and what's not going to work on the west side. Finding more of the viable options for cost-effective locations, being able to increase our production from storage. The other locations either had too much water main that was involved to connect to the system. It was also not centrally located to be useful for not only the existing system but for the future expansions that's known. So there was a couple reasons for the other 4 to not be as viable of spots to take a look at. Now, if later on the line, that's why we kind of show these other options, is if that something changes in the next 5-10 years of how things are connected in the system, we've now looked at these locations that could be an option for later use. But for the time being of how the system is currently used, the 2 options to the south on the west side is what are the viable options at the moment. Then lastly, is there a cost estimate for an elevated tower? So with the uncertainty of the steel market, the typical price range of an elevated tank is about $5 to $6 a gallon. So an example is a 750,000 gallon, which is our minimum recommendation. That would equate to about $4.5 million for that type of tank. So I just wanted to give you a magnitude of the amount of dollars that's involved with these discussions for the tank. That is the slides that I have to talk about, and how would you like to start questions? Yes, go ahead.
Can I interrupt for a second,
Sure.
folks? Ms. Sandberg, are you taking minutes? Are you doing the minutes, or?
You didn't officially notice the meeting, so I was just going to do a short memorandum.
Okay, do we need name and addresses for the record? No? Okay. My apologies.
All right.
We're ready to rock and roll.
Sure.
Okay.
Yes, sir.
For what you guys are proposing, and since we brought up cost on that last point, what are we talking total cost-wise for this entire project?
So that's, try to make sure that I'm answering it right. Is that,
Yeah, like what's the total cost?
so the total cost of the improvements that we're talking about is in the range of 20 to 30 million. That would be of the discussions. Now, with that said, remember that there's developments that's in discussion. That's certainly a lot of what the town is working on to make sure that it is put onto the appropriate people of how this is going to happen. But we're talking also that a lot of these longer range discussions, 5, 10, 20 years down the line, it's not all 20 million right away. So that's another thing to keep in mind of the time frames that are in. But some of the water main improvements that are involved, the expansion that's expected, it's kind of the magnitude similar to the price tag of water treatment plant, or the waste treatment plant is somewhere in that kind of magnitude of larger millions to be able to do that. So just want to be clear, like, the recommendations we have for it, that does not necessarily mean it's coming from the town, it's coming from developers. Like, that's the next steps of how things are going to be worked on with the expansion plans that are happening in town. Yes?
You had mentioned the southwest side. When is the long-term plan going to connect the southeast side and create a complete loop around the lake? How long do you think that's going to take, or has that have been discussed yet?
It has been discussed, not sure on time frame wise. So the theoretical means of the actual connection through the water modeling, it is viable to do that. Like I had said, with some of the restrictions and some of the obstacles that have to happen going from West Side, so from Parish Avenue over to Morris, there are a lot of environmental things to look into, the directional drilling that's needed for that kind of pipe to be able to happen. There are a few obstacles that need to happen for the connection points for that piece. I know there's discussions of moving to the south on the west side for development things that are happening. So from my standpoint of if it's connected into that location, the elevations are a good spot. There's lots of things that are positive to expand to the south for the water system. Yes?
For the people who have private wells, will we be forced to go onto this system?
That is not the intention of this discussion. So no, not to my knowledge.
No.
No, okay.
So we can all.
Not to my knowledge.
Yeah.
So what the master plan is talking about is that we have accounted for, if that does come to fruition, that if the option is available, if there's a water main that's now been installed in front of your front house for whatever reason, we've accounted for that kind of demand to be put onto the system to help with the storage capacity and with the size of the pumps and making sure that it's covered on that side too. So not trying to force you.
Two questions. One, we started off talking east and west. Now we're talking north and south. How are we differentiating those? Because it seems like restrictions are east-west based, and now we're talking south and north based.
Good question. The current existing systems are east of the lake and west of the lake. So that is the delineator right now. Excuse me. The north and south discussion are interconnects, or actual water mains that would connect the two for these discussions. So yes, the existing systems are still, the lake is the boundary of both of these water systems.
Okay.
And second question, yeah.
Second question is, we talked about the addition of private wells would be accounted for, possibly. What has the moratorium, if I'm using the correct word, on new construction, new home
Correct.
sites, is that still in place?
Not anymore, is my...
The building moratorium is still in place.
Oh, okay. Sorry.
Yeah, we're baby steps here.
Yeah.
So it is still in place.
Okay. So from this point, for notice of intent, from the standpoint of IDEM, the reasoning of the plan and the reasoning of the master plan is to be able to show those baby steps and to make sure that what we are adding in the near term is not going to stress the system, is what it's going for. Yes?
Half the town doesn't have fire hydrants, which I'm like a city person, so I was kind of shocked when I moved here. In new subdivisions rather do. There was a fire one Thanksgiving in a fairly newer subdivision, but they didn't have fire hydrants. So my Thanksgiving dinner, when I turned on water for my guests, was brown, orange. If there were a fire, God forbid, right now, and you have to take a water tanker truck, I understand, what happens to our fire hydrants if there's a fire on the other side? And even if there weren't, if there were a fire, say, like in Monastery Woods area, right now, would there be enough pressure in that fire hydrant to put the fire out?
Yes.
Yes?
For a certain amount of time, like, yes, the pressure that's there is...
What do you mean? I mean, I asked somebody else in the fire department, they said it depended on the time of day.
Correct.
I was
Yes.
like, what?
It
depended on
does.
the time of day? Because see, when I think when you buy an expensive home, or even if you don't have an expensive home, and you put your life savings into that home, you assume when you come to the area you're moving to that you have water and that you have good sewers. And when they are kind of like, see, they want the building because they get $2,000 for every building. For a church, I noticed they got $5,000 for these permits. That really builds up the revenue for the town. So if you're saying 3 to 5 years, so there shouldn't be any building then for 3 to 5 years, right? I mean, they're like, well, I don't know, maybe.
Trying to figure out which question to go with. I think what I'm trying to get at is the town is growing, and so going from what has happened in the last 15, 20 years in town, because of the developments, because of the master plan, that is the overall goal, and like what one of the statements was on the slide, is to increase everyone's available fire flow everywhere in town. So it's one of those things of making sure, and I know, I might be saying this wrong, but I think one of the previous methods from the fire department was to use dry hydrants or use the lake for their fire protection means at some point in life. So it depends where you're at. It depends what the day is. It depends on lots of things to that. It's not a general statement of that.
I'm not sure what you mean, sir, like it depends on the time of day again, when the fire exists?
Yes, I can tell you that with the water,
Does any other town have that?
it's with most municipal water systems.
Pardon?
With most municipal water systems, your tank is moving. You cannot have an elevated tank that is sitting stagnant for a good reason, especially in the wintertime. It'll turn into a popsicle, really. If you have a tower that is sitting at one level and it's 0 degrees out, it will freeze. So the idea of a water tank, it is a fluid, and the pun is intended, the fluid motion of an elevated tank to be moving at all times. So at the start of the day, that is the idea and best practice, to have your tank full as possible at 5 a.m., 6 a.m. to be ready for irrigation, be ready for bathroom activities, like being able to have your showers and bathrooms go at a 5 to 6 a.m. rush. Then, yes, it's going to start to go down during the middle of the day. Your pumps start to kick on and start to fill up your tanks.
Are you saying every town's like that? Highland would be like that? Like it depends on the time of day? Chicago's like that? Depends on the time of day?
Depends on the system.
Pardon?
I cannot answer every single system.
Well, you know, it's kind of scary, isn't it?
Next question?
And, I'm sorry, but when you say like it's growing and building, that was a problem.
Good.
I live in Crystal Oaks, and we moved there in 2015. We had great water. Now, she can't turn on the wash machine and turn on the faucet at the sink at the same time. There's just no water.
Okay.
Barely any water. Or flush the toilet.
Is that all the time, or is that
All the
recently?
time.
Okay.
All the time. It doesn't matter if it's in the morning, middle of the day, when everyone's at work, it does the same thing. So, I know you said the plant's 3 to 5 years. Am I gonna get that water back after 3 to 5 years, or is it gonna stay the same, and you're gonna start development again, and we're just gonna stay at the same level and not get,
So with Crystal Oaks, so here's I'll answer that. The Crystal Oaks tower that's right next to you,
what, 2-3 blocks away? Excuse me.
that the upgrades that happened at Robin's Nest was able to fill that tower to the top, okay? And so usually at the beginning of the day, that's at its height of what's going on. So Crystal Oaks, because of the elevation that it's there, you're usually in the 45 PSI to 50 PSI range that's at that area. That might be a discussion to either check with your service line, if that's always
I
been the
have a
case.
new water meter that was
Okay,
replaced
then,
last
yeah,
year
it's
already.
certainly the first thing to check off, like making
Yeah.
sure there's nothing blocking your lines, making sure that there's no obstruction.
Well, I know that with that water tower, it wasn't made to give us a lot more PSI. It was more for the fire protection, especially if there's a fire on the other side of the lake, so we could maintain some kind of pressure on our side.
The other,
Correct, or no?
I'm sorry, yes, you are correct. The other thing that's involved with that is that you don't want to go too high into your pressure. Your pressure at Crystal Oaks at 45 PSI, 50 PSI is also 80 PSI that's at this location. So there is a range you have to make sure that you're within to not be blowing mains.
I know that, I can't, if I wanted to water my grass, I haven't watered my grass, this is too expensive. It's sad to run the sprinkler out in front.
Okay.
Especially if you flush a toilet or run the dishwasher, anything. I just want to know, is that going to change with the 3 to 5 years? Or at that time at 3 to 5 years, you're going to start letting people develop and we're still not going to get the pressure and everything that we need?
Because of your elevation at Crystal Oaks, that is not dependent on the development, if that answers your question.
So if you make the improvements and then you guys start building a bunch of houses, it's not going to take away again from our side?
Should not, no. Because of just how the elevations that you have for where your ground is compared, you're on top of the hill. I would be very blunt. That Crystal Oaks is on the top of the hill and the rest of the town is really what's going on. And so the lake, your pressure difference that you have in the town is that Crystal Oaks at 45 PSI, 50 PSI, your town, the lake at the shoreline is around 75 to 80 PSI. So there's a very large swing within one pressure zone that's happening with that. So Trying to answer your question.
Well, at what point are you guys gonna, well, I should ask them, at what point are you gonna raise or let them develop? I mean, what's the?
Kevin, if I could add?
Yeah, go ahead.
Yeah, well, the moratorium was brought up, and there was a little confusion about moratorium, I think, over the past year, because in August of last year, we got a letter from IDEM stating we had some problems, and we met with the folks down there. So there's, people consider there was an IDEM moratorium, and then there's a Town of Cedar Lake moratorium. We actually passed a resolution here, this council did, to stop approvals of any new development in town, large-scale developments. So that's where we're at right now. I think that the focus of that was that we didn't want this resources to be diminished anymore. So I know you had asked Mr. Baldwin about, you know, are we gonna end up having some improvements, and then it's gonna be 3 years out, and then we're gonna end up losing all the benefits of those improvements. If we open the door to development, our goal is to have the developers pay for these improvements, and they would help everybody out that's on the water utility, not just their developments.
Are the development people are gonna pay toward what we gotta pay, 20, 30 million over the next 10, 15, 20 years? Are you gonna make them pay for it?
Yeah, well, let's not say, we're not gonna say you guys have to pay for it right now. We're still trying to figure all that stuff out with the finances. But I'm a firm believer that if somebody wants to come into town and development, wants to come into town and develop, it shouldn't be put on the backs of the people that are already here. It's just a simple theory I have. I mean, so that's where the negotiations come in with the developers. I think that Cedar Lake has a lot to offer, and I think that we can, we should set the bar pretty high on what we expect.
Go ahead.
Has any of your data or anything shown that any of our fire hydrants in town will be failed to give less than 10 PSI at any given moment, 24 hours a day?
The calculations we have, we aim for the threshold at 20 PSI. That's a IDEM, that's a EPA mandate to be able to do that for accounts. Say it again?
And that's what we're currently meeting, or is the system?
Oh, no,
meet that?
we're meeting that. No, definitely. It's much more of what events and what situation happens than what we have for the scenarios for each of the pieces of the three systems is what's involved.
Right. If I read it right, in the beginning of the slide presentation, I think one of the goals is to increase capacity by 1 million gallons.
I think it was saying that's deficient by that, of what the typical rule of thumb is of 2 times your average day. So you want to have, if there's 500,000 that you're using for each day, you want to have 1 million.
If that was a suggestion, 1 million tank, 1 million gallon storage, it would be an additional water tank, possibly at 1 million gallon capacity. Why are we looking at a presentation on the end where it said a tank would be 750,000 gallons instead of 1 million gallon tank?
Good question. So it's also, it's the fine line of making sure of the discussion of combining the systems, that if we do 1 million, that's added onto the west, you have your current 250,000, that's that parish tank, but then what's also, if the systems are connected to Crystal Oaks, with having all 3 of those pieces, we say that that's a minimum of 750. So yes, you could go further if you know known developments are coming in. If you have a large water user that's coming in, that certainly helps teeter the discussion to go larger for that. So that's why we say it's a minimum to help with the known development that we have.
I just think if you're going to do a tank, let's do it right.
Oh, totally. And it's a money game too. It certainly is a budget for something like I was saying, $5 to $6 a gallon. Like there's.
And it's a lot of money. I know.
Yes, definitely. So that's why knowing of all of the answers that are necessary for that sizing of a tank, that's why we at least start with the rule of thumb that the example for that too is that if you have 1.5 million gallons in the air, if pumps fail, if wells fail, you want to at least have a day to 2 days worth of your supply to fix the problem, to be able to have some kind of resiliency to your source being down for a temporary time. So that's why it's making sure of that number. Yes, sir. Yep, gotcha.
Definition, I'm a little confused on, you said IDEM moratorium, Cedar Lake moratorium. Are we having,
Kevin, would you like?
Yeah, I think that's why the moratorium discussion with IDEM was why it was
Yeah, do you want me to answer that, Kevin? Okay, so in 2024, the council, which we're missing a couple members, but Mr. Carnahan's over there, the council instituted a developmental moratorium. We did that by way of a resolution at a public meeting, that we put a halt to any new development. It was targeting mass development that sucks resources, I guess for lack of better words. So we did that. That was something we did. Now, fast forward to August of 2024, we received a letter from IDEM, and they wanted us to meet with them because they identified some problems in the water system. Now, these problems they predate most of us on the council. It's been going on for a handful of years. And when we met with IDEM, and this is, Kevin, where you might want to pick this up because you were there too, they had some restrictions on us there, and the NOIs were one of them.
Correct, yes. That's why I think the moratorium question we had before is that IDEM discussions of issuing the applications to put in new water mains, a little different than the moratorium of the development. So that's why I was going back and forth on the term. We might have...
Did that answer your question? It was kind of two-part.
Did IDEM put a moratorium on building?
No, I wouldn't even call it a moratorium. Like, we instituted a moratorium. That was the only moratorium. IDEM, right, and then the other stuff was IDEM had restrictions on the town of Cedar Lake with water main. I'm sorry?
They wouldn't approve any NOIs.
Yeah, they wouldn't approve any NOIs, which, you want to explain what the NOIs are, Kevin?
Yes, so the NOI is notice of intent, so that kind of application is what a new development or new water main extension to the system, you submit those plans, those specifications, that application to IDEM for them to review. That's where they do an initial comb-through of your capacity usage. So that's where what Ben was talking about at the beginning is that because of this master plan, and now that we have steps to move forward, IDEM has lifted that restriction to not approve any NOIs. So that's why, because of this plan efforts, because of what the board's been doing and trying to be proactive with this discussion, that has satisfied the IDEM restriction requirement that's been going on for this. So hopefully that, I know it's the same moratorium discussion, but IDEM was a separate than the building. Yes?
That gentleman knowing Al's been trying to get your...
Sure, I'm sorry. Go for it.
When you mentioned 45 pounds of pressure, is that hydraulic head? And then you go to your booster pump from there? Is that how it's all set up?
45 is the actual static pressure.
Right, hydraulic head.
Correct. So yes, that's the 80, 90 feet that's up in the air at that particular spot. So for what we were talking about with Crystal Oaks, how that works for the booster pumps at Robin's Nest is that the wells bring up the water to a ground storage tank.
Right.
It is then an air gap is what we call it, and then it is then re-pumped with booster pumps to get to the 45 PSI up the hill.
Up the hill?
Yes.
So that isn't boosting your hydraulic head to the overall head, correct? Or is it?
I think it is. So the height of the tower that is at Crystal Oaks is the example I'll use. That's your 45, 50 PSI. That is the height of that tower.
That would be your suction head on your pump.
The suction head would be a lot lower. That would be actually what's drawing from the ground reservoir.
You missed my point.
Sorry.
Let me start over.
Okay.
Your water pump in the ground pumps into the tank.
For which system? So the east?
It doesn't matter.
Yeah, it doesn't matter. So yes.
It pumps it into your tank.
Uh-huh.
From your tank, it comes down, doesn't go to another pump.
No.
So basically, your static head of the tank is what's supplying water to the residents.
Correct.
Without a pump.
You are correct. Yes,
All
that's
right.
the potential energy,
So
yes.
let me bring this up. Have you thought about, or does the system include, or are you looking at putting an inline booster pump to manage and control the static line loss as more people add on to it?
With this town, the area that you have in town, usually that's not necessary. Most of the time, booster pumps that are in line to a system is usually for disinfection purposes, for residual usage, but to add to the pressure of what you're trying to go for, it would only be localized at that spot. It would not be the entire system.
I'm going to go one step further,
Sure.
if you don't mind. Pumps are designed to maintain a specific line pressure from point A to point B. If the line pressure from point A to point B drops based on your pump capacity and usage, that can be changed to maintain normal line pressure.
So that is definitely the reason of the SCADA control systems. So with that said, if there is a sudden drop that's happening, it has a better reaction time to bring that pump back up to keep those pressures at a more stagnant location. That helps with the operators during a summertime usage. If they know that there's going to be higher demands that are happening June, July time, they're able to start the pumps up earlier before people open up their faucets and be able to keep that pressure up to there. So
Have they thought about putting VFD controls on?
they are already installed. So VFDs, variable frequency drives, are able to help modulate the pump so that it can keep the pressure, is what he's asking.
Kevin, one of the things with the SCADA system, it's not totally installed yet, right?
The east side system for Robin's Nest has been installed. We are already working on the west side and have the proposal already set in
So
stone.
what we have to do now, we have to manually go out there and turn those switches on.
Correct.
And when the SCADA system is in place, then if the water level drops, the SCADA system will automatically turn on one pump, and if it needs more, it'll automatically turn on the second pump.
Correct. Yes, SCADA systems will help with set points that are determined of whatever the height of the tower is to keep the pressures we're talking about at a certain level. If it does go below a certain level, kicks on a pump, starts to go from there. So yes,
to me, that doesn't cost a whole lot of money. What your controllers on.
hence why it was the first couple recommendations we had give right at the start. Yes, sir.
Since there's only X number of water, okay, maybe we have the town wells and we have the community wells. No, the personal wells,
Yes, private wells.
okay? The town well is 200 to 400 feet. Do the personal wells draw from the same aquifer?
Yes, they do.
So if,
Most likely, yes.
most likely, yes, at a shallower depth,
Yes.
okay? So if there's only, and on the west side, since that's where I am, I live in a subdivision that has community water, and just about everything else around me doesn't. So when you figure the usage of the maximum and averages, that's only on the community system?
Correct. The public water supply. Yes, I'll call it that way.
But if we're all drawing from the same water, how, if we add more, how is that going to keep up?
So most likely that kind of aquifer discussion is much more in a geologist to be able to work on draw stuff. A lot of that source discussion. I can tell you that same kind of capacities that would happen further south Indiana or Illinois area, you're talking the same kind of capacity that's pumping out of what you currently have at a larger depth, at 1,000 feet, 1,500 feet, 2,000 feet, because of how the aquifers are set between the states. So because Indiana is a little bit closer to the aquifer, I'll call it, the amount of capacity that you have of 400, 500, 600 GPM at Parish, and you're only going down 300 feet, like that alone is because of how the aquifer is set in Indiana. So that's the quick
Only
aquifer.
that much water, and we gotta figure out how to use it. Okay.
Mr. Baldwin, I have a question, but to Father John's point, maybe a little bit. I know there's a lot of people that have private wells that are concerned about, and I was hoping that some of that would get, and I don't know how it gets factored in, but I was hoping some of that would get factored into the water master plan, because there's a significant amount of private wells that have gone dry over the past few years. And, you know, I've heard people say, well, they don't come from the same aquifer, we go into the bedrock. Well, the water from the shallower water deposits seeps into the bedrock. Doesn't that get depleted, and isn't there effect on that could affect private wells?
Yeah, that would be my question of what the depth of the private well is, if it is at the same depth of what this is. So that's why I'm thinking that it's much more at 50, 100 feet.
Nowhere near that.
So,
The average depth about 80 feet.
yeah, so I think it's, yes, it's seeping into the lower reserve that's there, so it's really doing much more of an analysis on each of the properties of where to get the larger volume, the larger bowl of water is where to look. Yes.
Yeah, my question or my concern was kind of part of the, and thank you for all the information, it's useful, it's helpful. But I'm looking at what we're all talking about is water and how much water do we actually have. And my understanding from the state, I've been trying to get an answer about the integrity of the aquifer going forward. And it appears that the state of Indiana does not map groundwater levels, but most states don't, in all fairness. So how do we know what the integrity of the groundwater is? What data is that based on? And if you don't know, where do I find that information?
I think that's...
Because if we don't have water, then,
Definitely.
we don't have water.
And I know that there are a few aquifer maps that are on IDEM's website. I don't know if you have.
I think IDNR has some aquifer maps, and I think you'll see that the northern part of Indiana is actually pretty, actually the southern part of Indiana is thirstier when it comes to the aquifers. The northern part is actually pretty rich. If you look at the counties that are sort of along Lake Michigan, so Lake, Porter, LaPorte, et cetera, those are all with the shallower, to Kevin's point, the shallower depths, you get to more plentiful water supply.
The only information I found and the only maps I found on state websites is so outdated. It's like, we have so much building here in the last years. We continue to build in the county. And just last week, the Lake County Board passed an ordinance looking at, well, what if somebody wants to put in unincorporated Lake County? So they want to put unincorporated areas because then people can't vote it down. So here you get a data center, somebody wanting to come in that's using at a minimum 500,000 gallons of water a day, up to 5 million a day.
So to your point, I think from this whole discussion, I think what would be useful is that we can certainly look into the aquifer information so that we can help you post it on the website and lead the townsfolk to where they should go.
We need
Yeah, definitely.
historical data. I don't
As an engineer, I like data also.
responsive to that, and it's a big mistake. It's an awful big mistake. You got towns that are not even 50 miles from Lake Michigan that they're running out of water. So,
Yeah, we can certainly lead to some links and some information that I've seen from the aquifers for Indiana, so we can help you on that front.
all right, thank you very much.
So I heard the comment that said that previously some private wells have gone dry. I'm guessing that's due to the previous building. So what assurance do we have that when you're going to put the system into place and we're gonna, at some point, building's gonna come back, that we're not going to dry up our private wells?
So most of those kind of studies is further beyond this master plan, is how I'm gonna answer.
There's no way to factor the impact of the private well into what we do going forward. Is that impossible to do?
Not impossible. I think it's much more of, you would have to have much more of an expert to be able to go onto the aquifer discussions for that. Certainly a lot of the other straws that have been put into Lake Michigan, that kind of discussion has been talked about, certainly in the Illinois area, that making sure that the sources that they're having data centers, they're having larger users that are putting straws into the aquifer with that. So that's really, it's really much more of a larger study to be beyond this piece.
The problem is last one.
Okay.
If you pump the water into the tanks to get the 45 pounds, 45 PSI, whatever the right word is, I'm off base now, to the highest point, why aren't there check valves so that the lower points in that system are only getting 45 and the water is flowing away at a higher rate?
The systems are operating on a single pressure zone. And so how the terrain is in this area, I've certainly seen systems like you're talking about. Excuse me. With that comes maintenance issues for that kind of a check valve that happens going down the hill. Most of the time you would see that type of trickle-down effect, I'll call it, is when you're in mountainous areas, that it really goes from 45 PSI to start, it goes down the hill 80, 90. Once you get into the 80, 90 PSI range, you're getting in a very high pressure, hard for firemen to hook on the fire hydrants. You got mains that are bursting at that kind of higher pressure, and then you would have reducing valves, pressure reducing valves, to then knock it down, to then keep going down the hill. The terrain that you have here, that you are staying in the range of normal operations for pressure, and so that's why it's designed just to stay as a single pressure zone for each of the sides.
I thought you had said that the lakefront got 75.
It is, yes. So that's where, well, I've certainly seen other municipal water systems that operate 80, 90 PSI plus. They're newer systems. They have the appropriate materials, the pipes that can take on that kind of higher pressure. So it's really how things are designed, and it can take that pressure. It's just making sure that things are maintained appropriately, having flushing programs, valve turning operations, like making sure the system is operating at those pressures is what it is.
And that's causing the leaks that were...
So that's actually, yeah, so it's not just the pressures, it's also how the operation goes. As if there were VFDs or variable frequency drives, you'd have a pump that is on and off, and the term that's called is called water hammering. That's within the system that you want to make sure you don't have that. You want to try and keep it as steady as possible so that it minimizes the breaks. You have a question?
Yes. Okay, so you mentioned in your presentation about, what was it, testing for proper areas to put the lines, presumably around, around roads, like, so, okay.
Yes, you want to have it accessible for maintenance.
Right, accessible for maintenance. So, okay, my only concern, I'm sure everybody here knows that around this time of year, it's not just Cedar Lake, it's all the other town. They all do road work at the exact same time. And my concern is, okay, so if you have a water crew in there alongside road crews, would that, in other words, can you have two crews there at the same time and have it be timely, or is it one of those things, well, you gotta wait for the road crew first, and then you got the water people then?
Most of the time, the water utilities is happening first.
Okay.
Is how normal procedures would do it. You would have the water crew first, and then maybe a few months later, if you're able to actually have that line up correctly to do your road afterwards. Most of the time, it's very rare that you have both
Okay,
crews
so
going.
for the water crew, they don't need the road to be blocked?
They would have it would depend on where the water main is,
Okay.
but yes, they would have they would have the normal traffic control that's going around there.
Yeah.
So, yes, you would have to get into the locations. That's where a lot of the survey that we would have, it really is site dependent. And usually it's in right-of-ways that we would be off the road for that, but there are either existing utilities that are conflicts. It really does depend on the site. But
Sure.
if it was in the road, yes, the water folks would have temporary signs, of course, for traffic control, and then they would come back later to fix the road. So most of the time in those water contracts, we would have temporary road fixes in the quantities to make sure that it's appropriate to drive on.
Filling it in with like gravel or something?
What's that?
Filling it in with gravel or?
No,
you
not,
said temporary, right?
yeah, it'd be temporary bituminous or concrete, whatever it is,
Okay.
depends on the road. That's, yeah.
What's it cost to hook up to the water system? I got a house across the street, what would it cost me to get it hooked up?
For a house service?
Yeah.
I do not know that. Tim, do you know that?
Anybody got a question? Yeah. Anybody? If I wanted to hook up to your pipe outside to get to my house,
If you had a regular 5/8 meter, about 4,000.
it's about 4,000?
Yeah.
So for those who didn't hear the answer, it's about 4,000 for.
Yeah, 4 to 10.
No, about 4,000 for the system development charges in your meter, then you have to run the line.
Okay, so,
Whatever, I
so
mean, that-
system, so check it out, and then the meter, and then run the line. So, okay, all right. Okay, thank you.
Good.
And there's no pressure, so.
Well, I heard that. I heard that. I was more curious about it. But it's gonna be great pressure pretty soon. Trust me.
Good.
So just a clarifying question, so I can understand all the terminology things easier. Master plan, it sounds like it's a solution to improve the water distribution, but not the supply, or is it
One and the same.
One and the same?
Yes.
So we're looking to increase our supply of water and improve the, so it's.
As a holistic approach, yes.
Okay.
So this roadmap, it at least gets the improvements in the right direction. It also helps to know that most of these plans are like a malleable discussion, that if something happens, if the data center discussion, for whatever reason, happens of a large user, that changes how things are looked at. So it's really just showing a roadmap of if a developer comes into this location, this is your major water mains that are proposed to be around this area. It helps with the discussions of what needs to be part of the overall distribution system.
So, just more really quick thing. What kind of forecasting has been done with all these developers that want to come in? I know there's about 1,400 homes that are proposed to go down by where the golf course was, and there's another, whatever there, so how do you guys, just for my general curiosity, how do you guys forecast that?
Sure. For the developments that we know, I usually take, or what we usually do for the water modeling world is take a assumed demands that is for that particular development. So for instance, for the Lakeside South discussions, we have assumed an average usage and a maximum usage. So for instance, I'll just throw a number out for now, is 200 gallons per minute to be put as a load onto that area. What happens to the system? How does the pumps react? How does the tower react? How often is it changing over? So that kind of information is when we know more from the developers, we're able to draw out those water mains, we're able to help the sequencing of how things are connected. That's usually where more of that kind of data helps the water model be able to plug in those pieces of information. So we know of Lakeside South, we know of the developments on the west, we have accounted for all those major pieces into the master plan to then look for capacity usage and tank sizing, like we've talked about, to make sure that we are covering all of those pieces, and with the discussions with private wells transferring over, if that ever happens, that we are also covered on that side.
Kevin, I'm going to ask another dumb question. I know what you just said, that's calculations for proposed future development, and you factored in the 1,100 lots that are already approved, roughly. Those are all factored in as well. Okay.
Yes.
Are they assessed,
Sorry.
are they assessed the additional impact money?
Say again?
You said that any new lots, I think we just said 1,100, are the builders, have those lots been assessed?
They'll
The
have,
impact cost on our water
so far they
improvements
just
for
have
them to build?
they have development fees and tap fees roughly now, don't they? If they build on those lots, they have to pay the system development fee, and then before that property goes online.
Have we increased it to accommodate for the?
Tim has an answer for that on,
Well, yeah, I mean, all the new homes pay the system development charges for each home, and then they also, those developments are all installing all of that new water infrastructure that's in those neighborhoods. So those developers are paying to put all those water mains and fire hydrants and all of those lines in, and then they are, on top of that, paying the system development charge to tie onto the system to use the water.
What about paying for the 3 to 5 years where we're paying to the damn system? They're paying to that too.
Right.
Well,
Well,
that's the fees onto that.
That's what.
I understand the fees you're saying now,
Right.
but the money that it's gonna be coming out of us eventually, because
And that's
they're
what,
not gonna have a choice.
That's being worked on.
I mean, this,
Same type of thing.
that's why I said earlier, they should be paying for it,
Right.
too.
And everybody agrees, the same.
Just like the schools, they should be paid if they're gonna have more kids here. Let them pay for the schools too. Not always fall on us.
So we'll go for about 10 more minutes, and then if there are more questions, we'll certainly want to have a means to be able to gather your questions. Yes?
I wanted to ask a question based on preventative maintenance and how often should we be looking at our system. It seems to me that right now, this review and this master plan being put forth, is probably a little long overdue based on the development in the last 15 years. My question is, in a perfect world, should we be looking at this every 5 years? Is this something?
Yes, 10 years, especially with how fast that this town is growing, then yeah, it might be even earlier than that, just to, if there's larger
a number of
pieces.
homes that would increase, and all of a sudden it would.
No,
Want to do it.
I think it's really, you're at a crossroads right now of just where, your next larger step, if it's the well production, if it's the tank that's onto there. Yes, we could put it to numbers, but I think usually you wanna do a system update in 2 to 3 years of how fast you're going. We normally, like I said, it's 5 to 10 years typical. That's usually when you have a established water system that's not really expanding major pieces, like you have major backgrounds.
Growing per se.
Yeah, so that's why you probably have it a little faster than normal.
So we get this water to our house, I probably should know this answer. It leaves our house, so I guess it's gray water probably per se. Our dishwashers, our sinks, our toilets.
That goes to sanitary.
Okay, what happens to it then? Why is it not cleaned and come back to us?
It does not, no. No, it goes to sanitary wastewater treatment plant, or wastewater treatment system.
Yep.
So, yes. So, no, that is not gray water, it's not recirculated, that's definitely not the case. Okay.
In 30 seconds or sooner, what is a data control center? What is that?
Sure. So in the water world, what a data control center is part of large computers, like large capacity computers that are able to do computations and to be able to help with storage of things, storage of...
Because I'm reading that St. John next week is having a public hearing to inquire a lot from unincorporated Cedar Lake, so they can put their data control center there.
Okay.
So they can build millions of homes.
So so what I have known from reading into data centers, and it's almost the equivalent of doing like a bottling plant. If you're trying to make a beverage kind of thing. So what the data center piece is much more for the cooling capacity of what the use of water is for the cooling purpose of a data center, is why that's usually hand in hand with conversations, is what we've seen from developments that have happened in the Illinois, Indiana area. And so that's why a lot of...
Why would St. John want that, not Cedar Lake?
Why would, for the use of...
St. John's acquiring that lot so they can put that data control. Why are they doing it, not Cedar Lake?
I'm not sure. Yes.
I have a private well, I'm not on the public system, and I was concerned because there was so many wells going dry in the past year and a half. I did contact DNR, and they did come out and measure my well, and they can, for people who have wells that would like to have them monitored, I have a contact information, anybody that's interested after this meeting can see me.
If you can please bring up your contact up to here, then we can distribute that out to everyone. Yes.
I have a question for you, on what you just said. So with St. John wanting to scoop up that parcel of land over by 133rd and between State Line and Calumet, do you think that they see the predicament that Cedar Lake is in, and they don't want to get themselves in that situation, and they are scooping up water so that they can sell it back to Cedar Lake?
That would be news to me.
Yeah, I was about to say, I'm not sure of that answer.
Yeah.
Yes.
So the building moratorium, just to understand, is on until...
It's indefinitely. It's indefinitely, yeah.
Okay, so when a new tower, a new storage tank is built, what's the area that these aquifers draw from, like mileage-wise? So do you have any?
It would encompass the entire town. The aquifer is very large.
So-
Is that what you're saying?
Yeah, so that being said, when more tanks or towers are being built, and to Mr. Parker's comment, which is the reason I'm here, it's going to be guaranteed, basically, that more people's wells are going to go dry.
No. I don't think that's correlated. I think because of the depth that we are doing the public water supply at 300 feet, 400 feet further down than where the private wells are, I think that's a little bit
So
different.
the private wells, if they're 75 feet deep, that water's not still trickling down into the 200 or 300 or 400 feet deep?
It is. It's much more of how the bowl of how it's holding itself at that depth. That makes sense. Okay, well, it's trickling further down.
It's
Sure,
trickling
go ahead.
through, so it's sucking more water.
If your well pump is at 40 or 50 feet, you can have sheehy well if you want come out, they'll check the well pump depth, and they can lower it depending on the depth of the sleeve. So if you had to, they can lower the well pump down and increase or reduce that potential.
That's why I asked the question, I already had to do that to a couple.
Right. So my point, right, is the other one.
I know the water table's dropping.
Yes, it is. And so if you have problems, they can come out, they can lower your internal well pump, which will reduce that potential.
Well, they can only drop lower so far to
They
where
can
it's
lower, depending on the depth of your casing.
correct.
So if the
I
casing
understand that,
is
right.
200 feet, they can go down 200 more, but it depends.
Yeah.
But they can check that for you.
Last two questions. Yes.
Regarding the moratorium on building, is there a list somewhere, are there any developments that are basically grandfathered that happened and were approved before that moratorium? Is there a list where you can find anything that is, kind of predates that? And is there a number of new homes and developments you guys know what I'm talking
Yeah,
about?
there's a list, that's the 1,100, it's roughly 1,100,
1,100.
between, let's say 1,150 or something like that are already approved, platted, and are buildable right now. That's before the moratorium. And that didn't count anything that would get rebuilt or redeveloped in a pre-platted subdivision, which would be something that was platted before the town was a town.
Thank you.
Hi, my question is in regards to yours, asking about St. John. They're giving the impression that they want to obtain that property to get ahead of the building in St. John and be prepared with the water system. But when you read from Forbes magazine, it said President Trump and his son, Donald Jr., who came to St. John to sign a water project deal with them, actually has invested in a new company aiming to build data centers to address the growing demand of high-performance computing infrastructures, which are data centers. Are you taking that into consideration?
Those kind of large demands, usually what happens, like I call it the bottling water effect or the data center effect, that we're talking that they're using 500,000 gallons a day on average of the size of data centers that we've been seeing. So that kind of swing of a new improvement, like that's a whole different, that's doubling the amount that's happening at the west side alone.
Tried that in Porter County and they had a vehement revolt on it over there.
Right.
And that may be why they're here.
Yes, my point exactly.
From the water.
They come just to build as they're trying to give the impression.
Hence why
My impression.
Hence why master plans are a malleable discussion, because we try and assume of the developments that are known, we try to assume the demands that are happening onto the system. So it happens that it goes, we can at least analyze of what is necessary for that kind of an upgrade that happens, and be able to give recommendations on where wells would go, where tanks would go. Like that's one of those things where the viable locations we're looking at for the tanks, like if it is something of a data center type of large demand that would happen, that would sway the discussion of where the tank would go. It's just, that's how these kind of master plans will give you at least a picture, or at least a snapshot of what we are forecasting at the moment. If something of a large user like that happens, that's a reevaluation that we would come back to the board with and say this is our recommendations of something that would happen.
We can only have some control over what happens inside the town boundaries. We can only have some control of what happens inside our town boundaries.
Same question, would Cedar Lake provide water to the data center that's being built in the
We
unincorporated?
couldn't do that if we wanted to.
It sounds like we're worried about them taking the water, but they can't get it for months, can they?
Well, it depends on who's sharing an aquifer, I would imagine, right, Kevin?
Yes.
So they may get it anyway.
All right, last two questions. We'll do you, ma'am, and then we'll go back. So, two questions, and then we'll kind of wrap things up.
So let's just clarify, when you're talking about the three areas, so we're working on three separate
Correct. Yes.
for the locations that you talked.
Yes.
They're not connected.
They are not currently interconnected. Part of the discussions was to keep in mind of the option of if they were interconnected, what would the scenario be? And so that's why tank discussions are involved, well locations are involved. If it is possible to interconnect these pieces, how would that work? How would it not? Like keeping that in mind, there are some hurdles, as what was shown before. There are hurdles of environmental discussions to put that water main in that location. Yep.
I do have one question to ask. My landlord is saying that we can't use our water now, penalty because of the water outage. What's going on with that idea?
No.
He's on a private well.
Not sure of your scenario, sir. Not sure. Last question.
Yes, I would like to know when the consideration is made, when a subdivision is approved, is that a normal procedure where they put in the piping and then when it comes to getting drinking water, the responsibility goes to you? Or can we go back to, like, farm, who is one of the biggest builders in this town, and say, wait a minute, guys, we need some money because you built these great big subdivisions. So, is that a law, or is that something that that's a deal with you?
To make sure I answer this right, so the idea of the master plan of where these particular water mains are to be proposed to go to is to help the town with a roadmap of when developers come in, that they are then able to say, we need this infrastructure from the developers to be able to put this in to accommodate the upgrades and to help the system as a whole. Am I on track of saying that right?
No, well, I've been here for 10 years, and I live over there in Monastery Road subdivision, and you not only let them put in all the piping, but you also give them the water to cut the grass and all that other stuff. So your responsibility increases a whole lot when you okay let's say a 300-house subdivision, which I'm sure you have. And these are all the ones that came after I moved in up where I'm at now. And my question is, you guys shouldn't have to pay for all of this. That's my point.
Okay.
Okay.
Any other last, Nick?
I have nothing. No, very
If you have any
good.
other questions, feel free to get with me. You can email me, call here, and I will get those answered for you. So with that, I guess, we're adjourned. Thank you for coming.
Thank you very much.
Thank you.
Thank you.